In this video, we're going to talk about using a reference angle to evaluate trigonometric functions. To start, I actually just want to do an example. So what I want to imagine here is that I have an angle in standard position where the point -2, 3 is on its terminal side. I'm going to find the exact value of all 6 trig functions evaluated at that angle theta. All right, well, I think about my definitions of my 6 trigonometric functions. Sine is the y-coordinate over r, where r is this distance between the origin and my point. Cosine is x over r, and tangent is y over x. And I know the definitions of my other 3 trig functions, but I also know how to just use reciprocal properties for it. So the first thing I'm going to do is I'm going to find the value of r. R is equal to the square root of -2 squared is 4, 3 squared is 9, and that's going to tell me that r is the square root of 13. All right, so sine of theta, cosine of theta, and I'll just write them all down, and then we'll find their exact values. Nothing about reference angles in this, just using the definitions of my trig functions. And so y over r, 3 over root 13. I'll go on and take its reciprocal to write down sine. And hey, sine and cosecant are positive. I have a second quadrant angle, so that's what I expected anyway. Cosine's x over r, -2 over root 13. And again, we can go on and take its reciprocal. And then finally, tangent the y over the x. Take its reciprocal. And those are my 6 trigonometric functions evaluated at my angle. But now I want to see what happens if instead of doing that, I evaluate my trig functions at the reference angle. So now I'm going to do the same thing. For theta bar, the reference angle. All right, well, my trig function definition requires my angle to be in standard position. So I recognize my angle theta bar, but now I need to imagine that it is in standard position. Well, this is a first quadrant angle, so what I need to do is imagine that I've drawn it with the initial side on the positive x-axis. Well, I don't want to change anything about the angle, so the easiest way to think about doing that is just by kind of flipping this over and drawing that angle in the first quadrant. So I'm really just taking this angle and imagine doing a mirror flip over the y-axis. All right, well, that's really easy to kind of think about, because all that's going to happen is what was 2 units to the left will now be 2 units to the right. And so instead of the point -2, 3, I'd had the point 2, 3. And it's not quite drawn to scale, but if I do this absolutely to scale, I'd see that, hey, that is my reference angle. Those are 2 nice equal angles. All right, well, r would be the same thing. This calculation still works, and the only thing that's different is my x-coordinate's now positive. So writing these values down at the reference angle shouldn't take too long or even involve that much thought, which is good news. It's late on a Thursday afternoon. So let's see. Sine of this angle theta bar here in the first quadrant, y over r, so 3 over root 13, no change there. Take its reciprocal. The cosine of theta bar would be 2 over root 13, and that is different, but only by the sine. Root 13 over 2, and then finally tangent the y over the x. And again, that's different, but only by the sine. And what I hope we're thinking is that even if this had been a 4th quadrant angle and I flip it to make everything positive, only the sine of x and y could change. And so that whatever I evaluate my trig functions to be for the angle, for the reference angle, the only difference might be the sine. And that is the big deal about using reference angles. We get the same values of our trig functions evaluated at the angle itself, except for maybe the sine. So I'm going to write that down. the value of a trigonometric function evaluated at theta and theta bar differ by at most the sine. If I think about it, what I'm saying is that sine of theta has to be equal to sine of theta bar with either a plus or a minus out front, right? Not whichever one we feel like, but the plus or minus gets chosen by thinking about what quadrant we're in. And that's true for each of my trig functions, that there might be a plus or minus out front of the trig function evaluated at the reference angle to make this equation true, but it's always determined by that quadrant, thinking about our positivity chart from class. All right, so I'm gonna write this down for sine, cosine, and tangent, but it's assuredly true for cotangent, secant, and cosecant as well. This gives us a methodology for using reference angles to evaluate a trigonometric function. Using a reference angle to evaluate a trig function. Well, the first step, find the reference angle. And then the second step, evaluate the trig function at theta bar, and then affix, put on a plus or minus determined by the quadrant of theta. All right, well, this lets us expand what we can use our special triangles to do. So let's say someone has asked us to find the exact value of the sine of 120 degrees. 120 degrees is this nice happy angle. Its reference angle is 60 degrees. So if I think about my special triangle with 60 degrees in it, I'll be able to figure out the exact value of the sine of 120 degrees. So I have my 30, 60, 90 right triangle, and I remember how to label the sides, 1, root 3, and 2. All right, my reference angle was 60. Sine of 60 degrees is, well, that's the opposite over the hypotenuse, root 3 over 2. So sine of 120 degrees is either plus root 3 over 2 or minus root 3 over 2. Well, this angle's in the second quadrant where sine is positive, and so there is how I've evaluated the sine of 120 degrees. All right, well, let's now try the sine of 300 degrees. Again, let's draw our angle. 300 degrees down here in quadrant number 4. And if I just think about it, that's 60 degrees shy of a full revolution, so my reference angle is 60. Evaluate sine of 60 degrees. Well, I just did that. That's still root 3 over 2. But in quadrant number 4, sine is negative. And so there, sine of 300 degrees is minus root 3 over 2. The value of a trigonometric function evaluated at its reference angle or the angle differ by at most a constant, but we could also think of this as saying that angles with the same reference angle, if I evaluate them at a trig function, I get the same number, only differing by a plus or a minus. In our next video, we'll do a few more examples of evaluating trig functions using reference angles.